Today I would like to walk you through 4 examples of how to solve rational equations. There's a couple different techniques for solving this type of equation, but I'm going to use the one where we find a common denominator and we multiply each term by that denominator. So, if you can factor your denominator, you should do it at this point. All 3 of these denominators are monomial, which means they cannot be factored. So we're going to leave them just like they are. So how do I find that common denominator? I want you to ask, what is the least common multiple for 1, 5, and 5? What can all 3 of these numbers divide into? 5. And as far as the variables, v squared, and v squared, what can all 3 of these variables divide into? V squared. Once you've determined what your common denominator is going to be, I also want you to figure out what your excluded values are. Take your common denominator, set it not equal to 0, and solve. We can do that by dividing by 5 and then taking the square root of both sides. So v cannot equal 0. Now, let's take that common denominator, 5v squared. We're going to multiply each term in this problem by that common denominator. Now that we have our problem set up, we learned last week that when we are multiplying 2 rational expressions together, as long as they are fully factored, we can cancel monomials with monomials, and we can cancel binomials with binomials. If I have chosen the correct common denominator, then each one of these denominators should cancel out in this step. V will divide into V, and it will leave a single V. When something cancels out entirely, it leaves a 1. And so 1 times 1 gives me a denominator of 1, which means I do not have to write that. As far as the numerator, I'm going to multiply these 3 terms together. 5 times v times 1, and I get 5v. In my next term, again, I'm looking at my current denominator, and I'm comparing it to my common denominator. The 5's cancel, and the v squareds cancel. Again, leaving a 1 in the denominator. There is a 1 that remains in the numerator here, and that 1 would be distributed to both terms inside the parentheses. So the answer to this second fraction is v plus 2. In this final, again, 5v squared cancels out with 5v squared, but this negative sign changes things a bit. You need to think of this as a negative 1. So when you distribute it, make sure that you're careful with your signs. My answer is negative v, negative 3. Now it's time to solve. Let's combine the like terms that are on the same side. So now I have 5v, the v's cancel, and positive 2 with negative 3 is negative 1. Final step, divide both sides by 5. So v is equal to negative 1/5. Negative 1/5 is not my excluded value, so it's okay to go ahead and box or circle it. Number 2 gives us a second example where we have monomials in the denominator. Take a second, see if you can figure out what your common denominator is. Did you choose 3x squared? All of my numbers can divide into 3, and x squared is my largest exponent. Make sure you check for excluded values by setting this not equal to 0, so x cannot equal 0. Now it's time to take 3x squared and multiply each term by this new common denominator. Now that we have our problem set up, let's look for things that cancel. In this first term, the entire denominator will cancel out with the common denominator, leaving x squared minus x minus 20. In the second term, they entirely cancel out also. Since there is a plus sign here, I know that I will not have any sign changes. So my remaining answer is plus x plus 4. Write down your equal sign. Let's do this last one. Here, only the x cancels out one of these x's, and it does leave an x. To solve this final problem, I have to distribute 3x to both of the terms inside the parentheses. So I have 3x squared minus 12x. Because I have an x squared term in this final problem, I know that it is quadratic, and so my options are to factor, and if factoring doesn't work, I'm going to use quadratic formula. But in order to do either one, I need to get everything on the same side and set it equal to 0. So how do I know which side to move it to? I like to leave my x squared term positive, so I'm going to move things to the side where it will remain positive. I'm going to move everything to the right. Before I do this, I'm going to combine things that are alike that are already on the same side. Negative x and positive x cancel each other out, and I can combine negative 20 with positive 4 to get negative 16. Now I'll move things to the right by subtracting x squared and adding 16. Now I have a trinomial that can be factored. Let me move it up here so we have more space. My first question should always be, do these three terms have something in common? And they do. They're all divisible by 2. After I've done that, I need to see, will this trinomial break down into 2 parentheses? Can I think of 2 numbers that will multiply to 8 that will also add to 6? You're right, 2 and 4. Since they multiply to a positive 8, I know they have the same sign. They're both going to have the same sign as the middle term. Now it's time to solve. You're going to take each of your factors and set them equal to 0. This first part doesn't make any sense. 2 cannot equal 0, so we're going to throw that out. I'll add 2 to both sides, so my first solution is positive 2. And then I'll add 4 to both sides, so my second solution is positive 4. Neither one of these are my excluded value, so I'm okay to circle or box these. Example 3 is the first time that we will have to factor our denominators before we solve the rest of the problem. X plus 1 is a binomial that cannot be factored. If you cannot factor it, I want you to put parentheses around it. Now I have a trinomial. They don't have anything in common, so I'll go ahead and put down my 2 parentheses. Can I think of 2 numbers that will multiply to 6 that would subtract and give me 5? 1 and 6. Since they multiply to a negative 6, I know they have opposite signs. The larger term will have the same sign as the middle, so negative 6 and positive 1. This is the same trinomial, so I'll go ahead and write down its factors also. Now that everything is fully factored, we can get our common denominator. You need to pick a common denominator that includes one of each unique parentheses that you see down here. The common denominator for this will be x plus 1 and x minus 6. You can always go back and double check this. If I look at the first fraction, do I have this parentheses written down in my common denominator? The answer is yes. Go to the second. Do I have both of these written in my common denominator? Yes. And then go check the third. Do I have both of these written in that common denominator? Yes. The goal is to cancel out your current denominator. So you have to make sure that you have everything necessary in your common denominator to accomplish that. Now it's time to simplify. Let's compare our current denominator with the common denominator. Do you see anything that will cancel out? You can only cancel a parentheses with an identical parentheses. So x plus 1 will cancel out x plus 1. In this first problem, I'm left with a 4 and x minus 6. I will have to distribute the 4 in order to get my answer. So I get 4x minus 24. In the second part, the x plus 1 cancels with the x plus 1, and the x minus 6 cancels with the x minus 6. The only thing that remains is a positive 5. Now let's write down our equal sign. In this final problem, the x plus 1's cancel and the x minus 6 cancels, and so I'm only left with the 3. It's time to solve. Let's combine things that are alike. We'll put the negative 24 with the positive 5 and we get negative 19. I'll add 19 to both sides, so 4x is equal to 22, and then divide by 4. Simplify. 22 over 4 simplifies to 11 halves. Now, don't forget to check for those extraneous solutions. I can do this by looking at my common denominator. My common denominator had two different parts, x plus 1 and x minus 6. Both of these need to be set equal to 0 and solved. My first excluded value is negative 1, and my second is positive 6. 11 halves is not either one of these excluded values, so I'm fine to go ahead and circle it. All right, let's start this final example by factoring our denominators. X plus 5 cannot be factored, so I'll go ahead and put a parentheses around it. X squared minus 25 is the difference of two perfect squares. That factors into x plus 5 and x minus 5. X minus 5 cannot be factored, so I'll put parentheses around it. Take a second. Look at all of your factors and see if you can figure out what the common denominator is. If you picked x plus 5 and x minus 5, you were correct. Let's go ahead and do our excluded values now so I don't forget to do this later. Take each parentheses, set it equal to 0, and solve. My excluded values will be negative 5 and positive 5. Now, let's take this common denominator and multiply each part of the problem by it. All right, let's look for things that can cancel. X plus 5 cancels with x plus 5. So in this first term, I have a 3, and it needs to multiply times x minus 5. Once you do that distribution, you'll get 3x minus 15. Write down your equal sign. Let's go to the next term. Everything cancels on this next term, so the only thing remaining is the 4x. On this last term, only the x minus 5 cancels. So I actually have a binomial times a binomial. Make sure that you use FOIL, double distribution, in order to solve this. Once you solve this, you're going to get x squared. You'll have a negative 3x and a positive 5x, which gives you positive 2x, and then negative 15. Combine things that are alike, and then we'll solve it. Since I have an x squared, I need to move all my terms to the same side. So I'm going to move them to the right. Final step, let's factor and solve. Both of these have an x in common. So if I divide an x out, I'm left with x plus 3. If I take each part and set it equal to 0, my first answer is x equals 0, and my second answer is negative 3. Since neither one of these are my excluded values, I'm okay to circle or box my final answer.